Hey everybody, welcome back to another fun and exciting Algebra 1 class. Today we are going to be talking about addition property of the inequality. Now, if you remember, we did a lesson on the addition property of the equality or the equation. And we did that back in, I think, chapter number 2. But here we are in chapter number 4, and now we're doing the addition property of the inequality. This is on page 131. Page 131. And what this is it's kind of like a carbon copy of that other lesson. Nothing changes, okay? Nothing changes. What do I mean by that? Well, if you have a simple inequality like x minus 2 is greater than 3, what I can do is I can follow the same rules as I did in equalities to solve this. In other words, I am trying to get the x by itself. So I need to move the negative 2 to the other side. How do I do that? By adding 2 to both sides. That's going to cancel, and I'm going to get x is greater than 5. And I'm done. All right? Now, I know right now you're thinking, wow, I wish all the lessons were that easy. Well, this one does get a little tiny bit more complicated, but there is one additional step that we need to do now that they're inequalities, and we learned it in the last lesson. So what we need to do now is we need to take this and let me actually get a better line here, and we need to graph this. So 0, 1, 2, 3, 4, 5, and then we could do some negative points on here as well. I know some of you like to number these. I don't necessarily have to have them numbered. You can if you want, but then it would go negative from there. So what we're going to do is we're going to take this number right here. This is our critical number. Remember, we learned that in the last lesson. And we are going to circle our critical number. Now, we have to ask ourselves a question. Is it open or closed? And you look at the sign, and if the sign is equal to, greater than or equal to, then we would color it in. It's not, so we would leave it open. In other words, it does not include 5. Let me show you why it doesn't include 5. Let me take 5 and plug it in. 5 is greater than 5. No, that's not true. Okay, so it does not include 5. Now what we would do is we would kind of, this is what I kind of like to do, is I kind of like to take this and it's pointing this way to the right. So let's try a number to the right first. Let's try 6. 6 is greater than 5. That's true. So we're going to color this in. Now, you can test a point from the other side if you want to, but with these ones, it's not going to work. 4 is greater than 5, so this side doesn't work, okay? Now, you don't have to put that X on it. I just put that there to show you that you don't have to do it. All right, so here's what your answer would be. Really, in this question, there's two answers. This is part of your answer, and then this number line is the second part of your answer. You would really need to put both things because here in the chapter they're trying to teach you how to, yes, write with the inequality notation, but then also write with the graphing notation. In Algebra 2, I think we might get to it in this book, but I know for sure in Algebra 2 we add one more notation. It's called interval notation, and we'll get to that a little bit later. But basically for now, we're going to graph it, and we are going to write it as an inequality. Those are our answers. Before, the difference was this one right here was your only answer. You did this and you were done. Now you have to take that and you have to turn it into a graph with the inequality. So that's really the only thing different with inequalities from equalities. Let's do one more, and I think I can make this video really short. So not too challenging, but we'll do one that's just a little bit more complicated. Okay, let's look down at page 131, example 4.2b. 4.2b. we had 3x minus 2, then a parenthesis, x minus 4 is greater than, or excuse me, is less than 5. Is less than 5, okay? So let's go ahead and solve it. Whenever we're doing algebra, we always do what we can do before we start moving things around. So let's do this right here. That's a distributing problem right there. So we'd get 3x minus 2x plus 8. How did I get the plus 8? Minus 2 times minus 4 is positive 8. Don't forget to distribute that. You got to distribute. You got to give it to both of these guys inside of the parenthesis. Is less than 5. Now we just continue to do what we can do, and I've got some like terms there, and so I would combine those. 3x minus 2x gives me x plus 8 less than 5. And now I would just move this over to the other side. That would cancel, and I would get x is less than negative 3. X is less than negative 3. So, am I done? No, this is part of my answer. What's the next part of my answer? Well, it's my graph. So I'd put my graph out there, negative 3. And so I would circle the negative 3. So remember, this is my critical number. So I would take my 3 and I would circle my negative 3. Now, do we fill it in? Do we color it in? The answer is no, because this is just a less than sign. It is not equal to. Now, which way do we color? Well, you might be thinking, well, I color to the left. And, well, let's see. So this one would be a negative 4. So let's try the negative 4 to see if that works. Negative 4 is less than negative 3. That is correct. So we would go this way. Okay, and your graph should always have these arrows on them, your line graph, signifying that it goes indefinitely in both directions. There's no ending to a line graph. Let's see here, page 132. And I'll show you what happens here. This will be the last one that I do. I'll probably be able to get this video done in 10 minutes. That's pretty awesome, you guys. And I know that you like short videos. So here's one thing that some of you struggle with, and I'm going to show you part of what's going on when I keep saying don't just always pay attention to which way the arrow is pointing. So if I have 3 is greater than or equal to 4x minus 3x plus 3. Now, when we start solving this, we're going to just do what we can do. And so I'm going to combine those, and I'm going to get 3 is greater than or equal to x, or 1x plus 3. I would subtract my 3 from both sides. That cancels, and actually this cancels too. I get 0 is greater than or equal to x, and that is my answer. Now, some of you don't like this right here, okay? You want it to say x is greater than or equal to 0. You just want to switch those. The problem with inequalities is you can't just switch them because it messes up the inequality. Here's what you have to do. If you want to switch those, so if you want to take your x and move it over here, you can. You can say x and then 0, but you have to flip your sign. In other words, this arrow right here has to be pointing to the same thing. You need to point it to the x. Notice right here, it's pointing to the x. Over here, it's pointing to the x. If you switch, okay, if you ever switch it, you have to switch your sign as well. So let's go back to this right here. I want to graph it right there. To me, it's easier to graph it right there. I don't want to switch it. I don't want to mess with the whole sign thing. I just want to graph it right there, and you can, okay? So we'll go 0, 1, 2, 3, negative 1, negative 2, negative 3. We'll put our arrows on this thing, and now we'll graph it. What do? We come over here, and we graph one at 0. Is it equal to? Yes, it is, so we color it in. And now we have to decide which way to go. How do we do that? Well, let's call this 1 and this negative 1. Well, we plug it in. We just do the same thing. We test a point. let's test the 1, okay? So 0 is greater than or equal to 1. No, 0 is not greater than 1. So it's not going to go that way. Now, some of you are thinking, but look, my arrow goes this way, so I just need to color it this way. Wrong. That is wrong. And that's one of the reasons why I told you not to do it that way. Be careful. We have to test our points. So this one, we're going to plug in the -1 here for the x. And so we're going to get 0 is greater than or equal to -1. And that is true. So our line will go this way to the left. Even though our sign is going to the right, our test points told us that this goes to the left, and it's correct. Because if I switch this and write it x is less than or equal to 0, there now you see the thing going to the left. But if you don't understand that, go back and watch that again there. There's some little tricks there where it kind of starts to mess with your mind because it's pointing one way, but on the number line, it's actually going the other way. Okay? All right. Well, it was 11 minutes. I tried to get it in 10 minutes, but, you know, hey, what can I say? All right. Well, we'll see you later. You have a good one. Bye-bye.